Now, today I have brought new chapter, that is Pythagoras theorem. Today I'll explain Pythagoras theorem and its proof as well as its use also. Now, before Pythagoras theorem, first of all I'll explain about right angle triangle, because this Pythagoras theorem is related with a right angle triangle. Now, right angle triangle. Right angle triangle means a triangle having one angle 90 degree. Now this is a triangle. In this triangle, this angle is 90 degree. If one angle is 90 degree, then this triangle ABC is called right angle triangle. Right angle triangle. Right angle triangle. Now in this triangle, it has three sides, AB, BC and AC. Out of these three triangles, this angle is 90 degree. 90 degree, that's why it is called right angle triangle. Now in this right angle triangle, it has three sides. Their sides, these three sides have a special name. Now first one is, this one is hypotenuse, which we represent by as hypotenuse. Now, you should know the definition of this hypotenuse, which we write small as. This is opposite side of 90 degree. Opposite side of 90 degree is called hypotenuse. Is called hypotenuse. Now in this triangle, this side is, this is 90 degree, this is the sine of 90 degree. I haven't written, you have to understand this is sine of 90 degree, and this 90 degree, its opposite side is this one AC. This AC is called hypotenuse. In any right angle triangle, opposite side of 90 degree is called hypotenuse. And here is, now remaining two sides, they are called, one is called perpendicular, another one is called base. Now for this angle C, now perpendicular, another definition, perpendicular, which side is called perpendicular? Now small p, this is opposite side of reference angle, opposite side of reference angle is called perpendicular. Small p. Now opposite, now you have to remember these two definition. Opposite side of 90 degree is called hypotenuse. This is 90 degree, its opposite side is hypotenuse. And perpendicular, opposite side of reference angle is called perpendicular, small p. It means for angle C. Now I'll write here, for this angle C, opposite side of this angle C is AB. This AB will be perpendicular, and for this angle C, BC will be base. Now for this angle A, opposite of this A angle is BC. That's why for this angle A, BC will be perpendicular, this AB side will be base. It means for angle C, if we take this angle C, hypotenuse is same, perpendicular, I write in short form, P will be opposite side of, for this angle C, opposite side of this angle C is AB. Perpendicular will be AB side, and base B will be BC. For this angle C, opposite side is this one is P, and this one will be B. This one will be B for this angle C. Now for angle A, for this angle A, but for this angle A, perpendicular, P will be, for this angle A, which one is the opposite side of this angle A? Now for this angle A, opposite side will be this one. This one will be P, and this one will be B. Now opposite side of angle A is, that is BC. BC will be perpendicular and base. base small b will be AB. Now remember that for this angle A, this one is perpendicular, its opposite side is this one will be base, and for this angle C, opposite side of this angle C is this AB will be perpendicular, BC will be base. Now I have written there. And remember, for both, for this angle A also, for this angle C also, for this angle A also, hypotenuse for both edges will be same, that is AC. AC will not change. That's why from here what you have to understand, when reference angle with respect to this angle C, this one is perpendicular, this one is base. Now for this angle A, this one is perpendicular, this one is base. Now perpendicular and base will be different according to the reference angle. Which angle we take, according to that we have to take P and B. Now you have to remember this definition. Opposite side of reference angle will be perpendicular, and opposite side of 90 degree will be hypotenuse. Now these are the basic things you have to understand. You should have capacity to change perpendicular and base. Now here is I written clearly, you can write. Now after this I'll go to what is Pythagoras theorem. Now I love this one. And Pythagoras theorem, that is related with right angle triangle. Only it is used in right angle triangle. If triangle is not right angle, then it will not be true. Now first of all I write the statement. What is Pythagoras? Pythagoras theorem. Now Pythagoras theorem, it states that the square of hypotenuse that is h square. A square of hypotenuse means h square is equal to the sum of a square of perpendicular that is P square, and a square of base, that is B square. Now it states that, means Pythagoras theorem states that the square of hypotenuse h square is always equal to the sum of square of perpendicular and square of base, B square. That is, we can write mathematically like this: h square equal to P square plus B square. Now this is the relation of Pythagoras theorem. Now I will derive this. Now for the proof of this one, now in any right angle triangle, now you can see here, if this one is right angle triangle A B C, this one is hypotenuse, this one, okay, I'll take this one reference angle for this. If we do not take reference angle, if we do not mention reference angle A and C, then anyone you can take. If you say this one is P, you can take this B. If you take this one is P, this one will be B. Anyone you can take. But when we take reference angle C, when we refer any angle C or A, at that condition we have to write particular, perpendicular and base. We cannot write randomly. Right now, anyone, if you say this one is perpendicular, this one will be base. If you say P, this one will be base. Okay, this one is, in case of right angle, this triangle, this relation will be true. Now before this one, okay, how to prove this one? I'll prove this one also. Now to prove this, first of all, I'll mention here, I'll write this first. First of all, we'll take the help of area. By the help of area of a square, we can prove this. Now first of all, just as a note. You have to remember that area of a square equals to side a square. Side a square. Side means, since side means what you have to understand, side means length or breadth. Now in case of a square, in a square, length and breadth, their side are equal. L and B are always equal in case of a square. And now this one is a square means this one. Now to be a square, all sides should be equal. Each angle should be 90 degree. Okay, ABCD, this and this equal, this and this is all side equal. L and B equal. Length and breadth are equal, and each angle should be 90 degree. And remember that opposite side are also parallel. You have to remember, it comes in geometry. Right now this full, but here we have to understand length and breadth are equal, each angle 90 degree. Remember this. And area of this a square, we can write like this. Area of a square, by using this formula we can find area of a square. Okay, this. Okay, how to prove Pythagoras theorem? Okay, I'll drop this one. Remember this, we have to use this one. Area of a square is this, and another one is, now area of triangle. You have to remember this. Area of triangle, basic formula of area of triangle, A equals to half times base times height. Base times height of triangle. Now for example, suppose this one is a triangle, ABC is a triangle. Now to be height, line must be perpendicular. Okay, we have to draw perpendicular. Now this, okay, I have drawn this P. This one AP will be height. Now for this triangle, area of triangle ABC, in this triangle ABC, half base, this BC will be base and this AP will be height. Now by using this formula we can find the area of this triangle ABC. Now in case of right angle triangle, okay, I'll draw this one. In case of right angle triangle, if triangle is right angle, suppose this one is right angle triangle. Now in right angle triangle, ABC is a right angle triangle. Now in this case this is 90 degree. In right angle triangle, if this one is P, this one is B, say this is as. Now in case of right angle triangle, this area, okay, area of triangle ABC for this right angle triangle. Now we did this for any triangle. Now for right angle triangle, this perpendicular, if we say perpendicular is height, this one will be base. If we say this is height, it will be base. Now in this case, perpendicular, base, okay, BC, height, AB, height will be AB, or you can write half times B times P, perpendicular times base. Now remember this also, P times B or B times P, perpendicular times half perpendicular times base, or half base times perpendicular, height and base. One will be perpendicular height, another one will be base. Now by in right angle triangle, this formula will be this one. Okay, now okay, first of all we'll take a line. Suppose line this, I have taken a line. Okay, I'll say the name of this line is AB. Now in this straight line AB, take any point in between A and B. Okay, I'll divide this AB. Now in this AB, by the measure of this AB, I'll make a square. Okay, this, in this square ABCD. Okay, I have taken a square ABCD. Area of this ABCD. Okay, this, its side is AB, BC, CD. These all are equal. Okay, this square means each angle 90 degree, all side equal. Okay, this all side equal. Now I'll divide this AB into two parts. I'll divide this side of a square into two parts. Okay, I'll take a point here. Okay, I'll give this point. Now measurement from this point to this. Okay, this one is okay B, and this one is P. I'll take B and P. I have divided this side AB of a square in B and P. One measurement from here to here is B centimeter, from here to here P centimeter. You can say like this. Measure of AB. I have divided AB, side AB here. ABCD is a square. That is AB equals to BC equals to CD equals to DA. Now this is the a square. Now this AB, okay, side AB I have divided into two. Okay, this one is, let's say, X. This point is X, name of this point. This AB, AX and XB. I have divided this side AB into, from A to X is, let's say this AX is B centimeter and this XB is P centimeter. I wrote B and P, it means base and perpendicular. In terms of B and P, I wrote, actually you can write A and B also, C also, whatever you want. Now similarly, each side, this AB, BC, CD, all sides are equal. Now I have divided this much part, B centimeter, this much P centimeter. Okay, here also I'll divide this side also B and P, this side also B and P, this side also B and P. We have to divide. Okay, this one is, this much is another point. This side I have taken. This one is B, this one is P. Okay, here also this one is, this much is B, this much is P. Okay, B and P. Here also this much is B, this point B, and this side I'll take P. Now I'll join this. When we join, we will get 4 right angle triangle. Inside this square, we will get 4 right angle triangle, and this, okay, this one is H. This all will be equal. Why they are equal? Because this triangle, this triangle, this triangle, this triangle. In this 4 right angle triangle, base and perpendicular, we have taken same measurement. That's why they are congruent. Congruent means this area of this all equal. Now, and this hypotenuse, this again, this is small. Inside ABCD, we'll get another square, this square also. And its measurement H, this also will be H, this also will be H, this also will be H. Let's say this side H, that is our assumption. I have taken this measurement is B, this one is P. Now, one square, inside that square, there is one square, its measurement is H, and 4 right angle triangle are there. This 90 degree, this also 90, they are of equal area. Now, in this case, now, this ABCD, area of ABCD, first of all, area of ABCD equal to area of this square plus area of this 4 right angle triangle. Now, first of all, I'll write here area of a square ABCD, area of a square ABCD. Area of a square ABCD means side a square, this is our formula. Side, what is the side of, measure of side of ABCD? Side of ABCD has divided into two parts, P and B, that is P plus B a square. Now area of P plus B, this side AB, BC, CD all has divided into P and B measurement. That's why area of a square ABCD is P plus B whole square, and it will be P square plus 2PB plus B square by using A plus B whole square formula. Now area of this square, we found this. Again what can we do? Inside this there are 4 right angle triangle, they have same equal area. Now first of all, area of area of right angle triangle. Right angle triangle. Half base times height. Now half base means, okay, you can take any. Okay, let's take this one. Base is this B, height is this P. That's why B times P, area of this triangle. Now here are 4 triangles, 1, 2, 3, 4. That's why, therefore area of 4 triangles, they are of equal area. Measurement area of 4 triangles equals to 4 times half B times P. This one is area of one triangle, multiply it by 4, that gives area of this plus this plus this plus this, area of 4 triangle. This cancel this 2, that's why 2BP. Area of this 4 triangle is 2BP. Now I'll drop this one. We found area of a square also, area of triangle also. Now area of a square ABCD also we found, area of this 4 triangle also we found. Now this area of a square, now I write here area of a square ABCD. Area of a square ABCD equal to, now area of this middle, this area of this square, area of, okay, X, Y, Z, Q. Okay, X, Y, Z, Q. This is also a square. Area of a square X, Y, Z, Q equals to H square. I wrote directly. Side square means each side is H. Area of this X, Y, Z, Q. This square is H square. Now this area of ABCD equals to area of this square plus area of this 4 triangle. Area of this 4 triangle plus area of this square gives area of this ABCD. Now area of ABCD equals to area of 4 triangle plus area of X, Y, Z, Q square. Area of a square X, Y, Z, Q. Okay. Now area of a square ABCD equals to P square plus 2PB plus B square, and area of this triangle equals to 2BP, and area of this A square is H square. Now this 2BP and this 2BP, when they comes in same side, they will cancel. Okay, P square plus B square, I'll take this that side, 2BP plus H square minus, when it goes that side it will be minus 2BP. Now this and this after subtraction 0, therefore what we found, P square plus B square equals to H square. Therefore H square equals to P square plus B square, which is known as Pythagoras theorem. Pythagoras theorem. Now this relation is always true in case of right angle triangle. In any right angle triangle, A square of hypotenuse always equals to the sum means result of addition, sum of A square of perpendicular and A square of base. This and previous. Okay, this is the proof of Pythagoras theorem. Okay, thank you.